In this video, we're going to focus on evaluating expressions that contain fractional exponents around numbers that contain fractions themselves. So below you'll notice that we have fractional exponents around a number that is a fraction. And luckily for you, we've talked about what we do when we have a power on the outside of parentheses. And hopefully you're remembering that when we're inside the parentheses, if there's no exponent listed, this is really 1 to the power of 1 and 64 to the power of 1. And what we can do here to rewrite this in a way that's a little bit easier to solve is we can use that powers to powers rule. So we multiply 1 times 1/6, 1 times 1/6, and we end up with 1 to the power of 1/6, all divided by 64 to the power of 1/6. So this is a little bit easier to look at. We were able to take that fractional exponent and essentially multiply each exponent on the inside by that 1/6. Now, hopefully what you're thinking of next is that you know how to change any fractional exponent and rewrite it as a root. So that's what we're going to do here. We're just going to do one at a time. So the numerator we're going to rewrite as the 6th root of 1. And my denominator I'm going to rewrite as the 6th root of 64. And then from here I need to figure out the value of each root. And again, I do that one at a time. So here I'm trying to figure out what number times itself 6 times gives me 1. That would be 1. And then my denominator is what number to the power of 6, or what number times itself 6 times gives me 64? Well, that would be 2. So I've used my exponent properties to rewrite this into two fractional exponents. Then I rewrote those as roots and evaluated the roots using my powers resource. Now if I apply the same thinking to the second problem here, I'll have to the power of 1, multiply them each by 1/3. So I get 8 to the power of 1/3 divided by 125 to the power of 1/3. Then from here I rewrite them as roots. So I have the cubed root of 8 over the cubed root of 125. And then from here, I'm going to rewrite these and solve them one root at a time. So what times itself 3 times, or what to the 3rd power gives me 8? Well, that would be 2. And what to the 3rd power, or what times itself 3 times gives me 125? That would be 5. So here we're going to apply that same thinking, but we also mixed some negative numbers into the mix. So here if we look at part A, we're going to start by rewriting that as two fractional exponents. Remember, that's to the power of 1, as is that. Now because I have a negative number on the inside here, I'm going to keep a negative number on the inside of my fractional exponent as I rewrite it. So here I have negative 32 in parentheses to the power of 1/5 over. Then we have 243 to the power of 1/5. Then I'm going to take these and rewrite them as roots, leaving the negative on the inside of the root because it was inside of the parentheses. So I have the 5th root of negative 2 over the 5th root of 243. Then from here I can utilize my powers resource. What times itself 5 times gives me negative 32? Well, because it's an odd number, I know that it will work with a negative on the inside. So we'll have a negative 2. And then my denominator, what to the 5th power, or what times itself 5 times gives me 243? That will be 3. Then if I look at the next example here again, I notice I have both to the power of 1, so I can multiply them each by 1/6. So I have 729 to the power of 1/6 over 4096 to the power of 1/6. So then from here I can rewrite them as roots. So I have the 6th root of 729, the 6th root of 4096. So then if I start looking down my power of 6 column, I notice that 3 to the power of 6 gives me 729, and 4 to the power of 6 gives me 4096. Then my next example here, I notice that I have 16 to the power of 1/2 over 64 to the power of 1/2. So remember, we multiply each power in there, the 1, by 1/2. We then can write these as roots, so we have the square root of 16 over the square root of 64. Then I know that the square root of 16 is 4 and the square root of 64 is 8. So I have 4 over 8, and because I'm a good mathematician, I know that I can simplify that fraction to be 1/2. And then finally, my last example here, this negative out in front, I remember, is just a -1. So I'm going to leave that out until the very end. So I have -1 times, okay, these are both going to be multiplied by a 4th. So I have 1 to the power of 1/4 over, that looks like 10,000 to the power of 1/4. So I rewrite this with roots, leaving that -1 on the outside. So I have the 4th root of 1 over the 4th root of 10,000. Okay, then I have what to the power of 4 gives me 1, that's 1. What to the power of 4 gives me 10,000, that's 10. So then my last thing here is I have a -1 times 1/10, so I simply have a -1/10 as my final answer.